Conditionals in Python. Let's start off with what exactly a variable is. In Python, a variable gives data to the computer for processing. In the case of x equals 4, the variable x equates to the number 4. This variable will be used throughout the section of code. The variable may be used with equations, printing instructions, and more. For example, x plus x would equate to 8. Alternatively, print x would command the computer to print the number 4. A code can have multiple variables within it. A second variable in this case might be y equals 3. As you can see here, we defined two variables, x and y. On line 3, we added a line of code that instructed x and y to be added together, creating a new x. Finally, on line 4, we instructed the computer to print our new variable x, resulting in the number 6, the sum of our original numbers. The details are important in Python, so make sure to keep the variables consistently capitalized or lowercase so that the computer knows exactly what you're trying to reference. After a variable is defined, we can instruct the computer to print something that varies based on whether a condition is met or not met. If the condition evaluates to true, aka the condition is met, one result will print. If it evaluates to false, aka the condition is not met, something else will print. But what does this mean in practice? Let's look at some examples to understand conditionals better. There are multiple types of conditional statements in Python. Today, we will be discussing if, elif, and else statements. If statements contain code that will be executed if a certain condition is met or true. Take a look at the example pictured below. X equals 3 and y equals 6. Z equals y divided by x, so z equals 6 divided by 3, or 2. Our if statement says to print x if it is true that z is less than 1. We know that 2 is less than 1, so our conditional statement is true. When we run the code, we see that our logic is correct because we get the number 3. If the condition in the if statement is false, the code within the if statement will not be executed. That is where else statements can come in. An else statement contains a block of code that executes if the condition in the if statement is not true. Let's take a look at the example we just had. We know that z equals y divided by x, and so z equals 6 divided by 3. That gives us 2, which is greater than 1, so the conditional statement is met. But what if x equals 12? 6 divided by 12 is 0.5. The condition in the if statement is false. Thus, the else statement will be executed. Y is printed, and we get 6. If a given condition is false, we can evaluate a different condition using an elif statement. In our example below, z equals 16, so the condition in our if statement is false. The elif statement evaluates if z is greater than 5, which it is. Thus, the computer will print z and we get 16. Elif statements are similar to else statements, but they differ because elif statements evaluate multiple conditions. Here you can see a simple example of how all of the conditionals can work together. The user starts by selecting a square, circle, or filling in their own choice. If they choose a square, they are prompted to choose once again between a triangle and an oval. They then enter another if-else conditional where the triangle choice leads to the winning answer. Alternatively, if the circle was chosen, the elif option runs and the user finds out that their answer was incorrect. If anything other than a square or a circle was chosen, the else runs and the user finds out that they lost. This is the Python version of the flowchart on the previous slide. What is going on here exactly is what is going on in the flowchart. Different inputs by the user lead to the execution of if, elif, and else. You can see how if, elif, and else can all work together in the same set of code. Here's a more complex use of conditionals, but it is using all of the same principles that we have just discussed. Think of this code as having multiple parts. The second line of code prompts the user to make a decision between the right and left boxes. Once the user makes a decision, the if and elif statements evaluate. A user who chooses the right box follows the trajectory of the if, and the user who chooses the left box follows the path of the elif. But within the if and the elif statements is an opportunity to make a second decision, triggering a second round of if and elif evaluations. This code prints a final result after only 2 rounds, but this style of repeated conditionals can be used to create a program that allows for many decisions. Let's say you are making a new email address and the minimum age for creating in the email is 13. When the computer asks you to input your birth date, it triggers a conditional. If your birthday is before 2008, you will be brought to the next screen to create your email address. Else, if your birthday is 2009 or later, you will be brought to a screen that tells you that you cannot create the email address. It can also be an elif statement here. The else statement will be used if your birth date is not 2008 or earlier. The elif would be used if your birth date is not 2008 or earlier, but is 2009 and later. As you can see here, conditionals have many practical applications on the websites that many of us use daily. By understanding conditionals, we get a much better understanding of how the computers know what's to output based on the inputs that we provide. The intersection of psychology and computer science programming is a relatively new field that individuals are still exploring. With programming language design, we can link that to decision-making and reasoning, which the frontal lobe is responsible for. Here, we can see a screenshot of a program with if-else statements that can represent decision-making for the user based on the answer that they give. For example, if the user decides to move straight in a maze, there are more options for them to choose what to do. More fields within the intersection of psychology and computer science include artificial intelligence, human-computer interaction, and machine learning. Machine learning is a method of data analysis based on the idea that systems can learn from data and identify patterns. This is similar to classical conditioning in psychology, in which humans learn through association based on response and stimuli.